Hello everybody, this is Blaine Lakin, Mr. Lakin, and I am working on completing the notes for Unit 2, Section 1.1, which is combining like terms. This is part 1 of the notes, and then we'll do part 2 in another video. And the objective here is to be able to manipulate algebraic expressions by identifying and combining like terms with integers. So we'll start off by describing what an algebraic expression is by defining it first. I'm going to go on type because if you have me as your teacher, you know that my writing is terrible and atrocious. An algebraic expression is a mathematical statement that contains letters and numbers and symbols like addition and subtraction and multiplication and division. And just to define things a little bit more here, the letters are called variables. And the numbers, there could be a few numbers here. The numbers could be something like a coefficient, which we'll go over in the next video, a constant, or an exponent. So all of those are numbers that could belong in the algebraic expression. For what like terms are, now we're not going to use that just yet, but what like terms are going to be any variables that have the same, that are exactly the same, but they may have different numbers. Particularly the coefficients. We'll go over again what that term means in the next video. And next, let's see here. We're going to write our own algebraic expression below using these terms. And these terms are going to be something, what we could do for an algebraic expression, something like 3 plus x minus 5x plus 8y. You'll notice that I just put these plus signs here just because I felt like it. There's no particular right way to do this. To write an algebraic equation, something I could do is 3 plus x equals negative 5x plus 8y. So that when we compare both of these, they look almost exactly alike, but the glaring difference between the two of them is going to be that equal sign. And that equal sign is what defines and distinguishes an algebraic equation from an algebraic expression. So to answer the question here, what are the differences between an algebraic expression and an algebraic equation? The difference, I'll say there's probably just one. The difference between an algebraic expression and an algebraic equation is that the equal sign is in an equation. And this is important for later on because some students, when they're trying to condense stuff and solve things, they actually end up solving for x in the left, and that is not correct. You cannot solve for a variable in an algebraic expression. Cannot solve for a variable. In a equation, you can solve for any variable. So that is the big difference between the two of these. A similarity, because there's a student that brought that up, is so there's a difference between them. What's the similarities? The similarities between these two is they both contain terms. Okay, so we got this first page taken care of. Hopefully not terrible. Let's go to the next page. And if I went too fast, remember you can always stop and rewind so that way you can get that support that you're looking for. The next part, like terms. Okay, we're defining it again. And we still haven't used like terms yet, but we will actually use it in this next example. Again, the way I define like terms is it is any number, any variable that looks exactly the same, but it has different numbers in front. And we're going to go to constant term here. The constant term term is a number without a variable. And you'll see there's some constants here in just a minute. So again, if that went too fast for you, please make sure you pause and catch up on the writing. Make sure you're understanding what's going on, that you can explain it in your own words. And otherwise, I'm going to go and move to example 1. Below are some animals that are holding terms. Draw a line to connect any like terms. So I have a blue line. I see an X here, and I'm looking through each of these, and I see an X there, and those are like terms. So I'm going to draw a line between those. It also looks like they both have dogs, which is good. I'm going to skip the cat for a second. I'm going to look at the bird. The bird has a 3, so I'm looking at any of these to see if these have a 3. I notice that this has a 3. Notice the bird is not the tiger, though, so I don't think that's right. More importantly, the variable on the tiger is the y squared, and the bird does not have a variable. So in fact, what we'll do to match the 3 is we'll go with the negative 12 because these are both constants. And constants can always be grouped together because they are numbers without variables. Now for the last one, we have y's, and you'll notice that I have a y squared here, so those look very, very similar. But remember that to be like terms, and I'll scroll up just for a second here, to be like terms, they need to look exactly the same. And if you drop those numbers in front, if you drop the 8 and the 3, you'll see y and y squared are not exactly the same. So 8y and 3y squared are not like terms because of that exponent. Okay, this next part we're going to go and group any terms that are like. And here we go with that. First, I'm going to go ahead and get rid of this weird thing up here because that's weird. Number 2, we have negative 2x, 3z, 5, negative 12, all these terms here. And what we're going to do is we're going to group them. I see that this negative 2x will go in this box. Remember, notice that this is the x term. I'm going to use different colors here. 3z will go in this box. The reason it can't go in the negative 2x box is because this is not an x term. This is a z term. This 5 is not an x nor a z, is neither an x nor a z. It is just a regular old 5, and it is called a constant term. And if you need a reminder, that constant term is a number without a variable. So 5 has no variable, and that is called a constant. And negative 12 is the same thing. A number without a variable, that's also a constant, going in the constant box. Now look at this, I got a 4z squared here. Oh my gosh, I could put this 4z squared here, but can I? I cannot because they are not exactly the same. Remember, like terms need to look exactly the same. And the number in front of them might be different, but the terms themselves need to be exactly the same. So we're going to throw 4z squared here into this box, and we're going to call this the z squared term. And the z squared term is a lot different than the z term. The next one I have up is going to be 3x. 3x looks like it's an x term, it's just the number in front is a little bit different, which is totally okay. So 3x goes with the x term. And finally, we have the 5xz term. The 5xz term, well, I have an x and I have a z, but I don't have them together in one box. So we'll put them together here as a different term with 5xz. And that's it. Looking at that page, we want to know which number is the constant term. The number that's the constant terms are going to be 5 and negative 12 in that list. So I'll put here 5 and negative 12. I wrote it down a couple times in this video, what are in your own words what are like terms. You try to put that in your own words now, and then that should take care of it. And then for the reflection, recap, closing question, please make sure you fill this out. If you felt like this, you were not confident in this at all, like a 1 or a 2 in grouping like terms, then what I would recommend you do is go to completing like terms part 1, and that's going to give you a little diagram with some trees and allow you to kind of understand how to group terms a little bit more. If you feel like you really understood this video, you are welcome to go ahead and go on to part 2 of the notes. Thank you for watching.